but I'm going to get started. So, first thought on parametrics is, what is a parametric? You just learned about them, right? And you're going to have an x equals equation and a y equals equation. And what does each of those equations have in it? T. So here's the parametric. X equals 2t and y equals t squared. Could that be a parametric? Yeah. We never did one with squared before, just because, hey, we had a lot to teach you on the first day. But this, if I asked you to graph it, it's just as easy as all the others if you understand the process. What do you need to be able to graph it? A txy. And one more thing that a parametric always has, always is a big word, we will always have one of these. And if you don't have one, it just means that everything works. But they always, in our lessons, will say, like, t is between 0 and 3. And I'm going to say or equal to. We usually don't mess around with, like, not equal to. All right, so I'd like you to put in 0, 1, 2, and 3, and tell me what x and y are. I will pause for a minute while you find those points. Again, just to be clear, if t is 0, I'm just putting a 0 in for t and figuring out what x and y would have to be. Pausing. All right. You guys verify these are the same points that you had. Raise your hand if you guys agree on this. Okay, good. And if I graphed it, what's different than just graphing normally? Do you graph the t? Yes and no. Here's why, what I mean by that. If we graph these points like 0, 0, I don't have t as one of my axes. It's x and y, but you're supposed to put right next to it a little t equals 0. Okay? Then, if I have the point 2, 1, I'm supposed to label it with t equals 1. And 4, 4, and 6, 9, and it looks like it's curving. What the heck? It's not a straight line. Well, it's got squares in it. That's why it's curving. Make sense? Okay, now, if I go like this and just connect my dots, and I put an arrow on it like this, and I had labeled every dot, then I'm good. Okay, so just don't forget the labeling every dot part. T equals 1, t equals 2, etc. All right, that's the only thing I'm afraid of, is people are going to lose some credit for not being detailed on their graphs. Got to know which direction it's going. All right, and then I taught you yesterday how to change this over. Change it over to what? Rectangular. I'd like you all to try that right now. Try to change this to a rectangular. It's a little more complicated than before. Solve this one for t, solve this one for t. And that's a little more complicated than you might think. Well, it's not that hard. You just divide by 2, divide by 2. T equals x over 2. Truth. Robbie, you put that up here. Thank you. And let's have Tadros. When you square root both sides of this, do you know what happens? Okay, this becomes t equals the square root of y, but that's close, but that's not right. Who remembers? Absolute value. Absolute value of t. You are solving for t. And so that's the one that gets the absolute value. And then you get two equations. T equals the square root of y, and t equals negative the square root of y. That makes it much more complicated. Okay, so if you had to switch this over, you now have to set this equal to this, and separately, this equal to that. You'd have two separate equations. to make this happen. I mean, you could do that. That would absolutely be true. All right, last thought. I'm going to do that then. X over 2 equals the square root of y, and x over 2 is equal to negative the square root of y. Please be careful that you don't ever end unless you've got a limiter. Yes?
You only solve for x on the equation, or solve for t on the top equation, and then plug that t into the t on the bottom equation, and it would already.
And the problem would be it wouldn't work. I get what you're saying, but you wouldn't have both equations. See, what I know that you might not know is that when you solve for like something that's supposed to look like this when it's done, it'll look like you only have this. And you need the negative of that to make it flip. So you need both parts. And I do get what you're saying. But if you don't have both of these parts, it's not going to give you the complete picture.
Even if you got the x over 2 squared, though, then it would still be y.
If you end up with something with the same exact thing as me, that's cool. But if you don't have the possibility of getting both a positive one and a negative one, then your way is not going to work. Could your way, when you solve it, get you a positive and a negative or not? Okay, check that out, because if you solve for y, if you get it, or sorry, x, get it down to solve yours for x, and if you end up with two parts, one with a positive and one with a negative, then it's okay and it works. Yes? I want you to show this step. Too many people think that the square root of t squared is just t. I don't want to be one of the teachers that allows you to think that. What I'm getting at is this. If you show me this and you go, oh, so I'll just do it in my head. X equals plus or minus 4. Nope, no, that's not okay. Even if you show me this intermediary step and then you say that, what you're saying is that square root of x squared is x, but it's not. The square root of x squared is the absolute value of x. So I want you to show that. You have to show that you've got an absolute value. And then you can take the final step to say plus and minus. No, don't skip that. It's too important. Too many people think that the square root of x squared is just x. And it's not. You can show it on a graphing calculator, but again, I don't want to make this a soapbox thing. Just show the absolute value. All right, last but not least, this is not done because it doesn't have a limit. I got to know what x can be between. Well, I'm going to take it right off my XY chart. These are so handy because they help you in graphing and they also help you right now. X had to be between 0 and 6. Why can't I say t? Because if you put t in there, you're making it back into a parametric. So x had to be between 0 and 6. Yep. Does this have all the pieces that we need to make it rectangular? Yeah. It's got my equations with x's and y's, and it's got a limiting factor. Yes?
So when you solve it, you have, I think the y equals x over 4 for both. Is that okay, or should one be?
The y, when you solve it, what?
For both of the new rectangular equations, that y equals x over 4.
Oh, you're solving them for y. So just a pro tip, don't solve these for anything unless they tell you to, okay? But if you squared both sides, I can see how you might end up losing your negative, and that wouldn't be good. So just be careful. If you actually solve it and you get the same exact thing on both equations, then you did something wrong. All right, so moral of the story, don't solve it unless I tell you to solve it, because you're more likely to make a mistake in it somewhere. Okay, let's do another thing from yesterday to make sure you get what's going on here. X equals 4t. Y equals t minus 8. It should take you about 3 seconds. Make that, oh wait, I gotta say a t. T is between 0 and 1. Make that turn into a rectangular. I'd still make a TXY chart. You know why? Because I need to know X. Because otherwise you'll have your X limit. So I'd still make a TXY even if I wasn't graphing it. So your goal here, make an equation that's only got X's and Y's and has a limit. And then you're going to compare it to the person sitting next to you. Actually kind of makes sense. You really only need the X numbers. So when you put in 0, you got 0, 0. Oh, okay. So if you're going to put in 0, maybe you do have -8, but you don't need that. You only need the X numbers. So I'll ask again. What'd you get on the XY chart here, or the TXY? You got 0 goes with what?
0 goes with 0.
Okay. And 1 goes with? 4. All right. Why was that important? Because it tells us our limiting factor now. X is between 0 and 4. So at my end of my answer, I got to say X has to be between 0 and 4. And this solves for T as T equals X over 4. And this solves for T as T equals Y plus 8. And then since these are both equal to T, this equals this. So there's your equation. I'm saving a step by saying that equals that. And that's the limiting factor. Raise your hand if you had that one right. Okay, good. You're all caught up, and we talked about squareds. So then, you know that these can be different things. I'm going to show you one more thing that it can be. X equals cosine theta. Y equals sine theta. But is that? Can that be considered a parametric? Not yet. But what if I said theta had to be between pi over 2 and pi? Now is it looking more parametric-ish? Do you remember me saying yesterday that you don't have to have a t, that it could be some other letter than t? Would you agree that there's 3 variables, x, y, and that's a variable? Okay, so it doesn't have to have a t. All right, and it could have a theta and then say between here and here, so it's still a parametric. Theta xy table, txy is what it used to be, is still in effect. I'd like you to just find the first point for me. After that, you'll know what to do with the rest of it. What if it's pi over 2? Would you please figure out cosine of that, sine of that? I'd draw a little picture every time if I was doing it, just to make sure I was remembering what cosine of pi over 2 was correctly. Do a circle trig to find it. So you go like this, and you go pi over 2, that's here. Oh yeah, this is one of those quadrantals. 0, 1. How do I get cosine of that then? Cosine's the x, so it's 0. And if I was going to do the y, I would go sine of it, which is the sine of the same angle, which is kind of handy. Sine is the y, so it's 1. 0, 1. That make sense? Any questions about that? All right. So, that last new thing that I want you to talk through with me. Oh, wait, actually, there's 2 more things. Let's say I just wanted to go from this point right here to this point right here. And I wanted it to go in this direction, but I wanted it to stop along the way. So I want it to go from 1, 2 to stop at, let's say this is 4, 5. I wonder if anybody here is strong enough in the force to be able to write me a parametric without any help. I want to give you a minute. Just try to write me a parametric equation that would do that. You know what's in parametrics. It's got this, and it's got that, and it's got this other thing. See if you can do it. If you can't, at least you'll be establishing in your brain that, yeah, I don't know how to do that, and you'll be able to pay attention better. Somebody in here is going to figure it out, I bet. Maybe 3 or 4 of you.
I'm kind of stupid, but I just
It's
have
okay, try it.
x equals t
X equals t, keep
and
going.
y equals t plus 1.
Y equals t plus 1. All right, let's just see if yours works. One more thing, you'd need to have a t limiter thing.
Yeah, I do.
What do you have?
I have 1, or x is in between 1 and 4.
You'd want it to be t because this is a parametric, but I'm going to go with t is between 1 and 4. Now I'm just going to show if yours works or not, and it's not that hard to show. I just make a txy chart, and I see if I really start, and I start at 1, 2, and I go to 4, 5. Does yours work or not? We'll find out. I'm putting in a 1 right here, and then I see what I get for x and y. If I put in a 1 for t, I get 1 and 2. Huh, look at that. It started, right? Okay. And then let's see if at 4, when I put in a 4, if I really get 4, 5. I put in a 4, and I get 4, 5. Double checking you. I feel like you're going to be right. When I put in this 4, do I get 4, 5? Nice. Mine's kind of dumb. Yours is great. Totally works. Is there another way to do it? Yes. In fact, there's an infinite number of ways to do it, but only a few of you will find them. You found one. Did you find one? Give me your way.
X equals t minus 1 and y equals 2.
Okay.
And
T minus 1 and y equals t. Okay, and then your t limiter?
2 is less than or equal to t, which is less than or equal to 5.
And so how do I check you? Plug them in. Plug them in on the txy chart. It's always coming back to that, isn't it? Okay, so then I'm going to put in t equals 2, and I see what I get. I put in a 2 right here and here. Did that give me 1, 2? It certainly does. What if I put in t equals 5? Then I get 5 and 5. 5 minus 1 is 4, 5. Totally works. Your answer is proven to be correct. Now, I'm going to give you a way that will work every single time. Because there's some of you, they're like, I don't know how they got that. And I can't explain for you how they got that. They just played with the numbers until they made it work. Okay. What are the pieces you had to have? You had to have x equals and y equals, and t is between a couple things. Those are things you had to have. All right, so here's a way that will work every single time, so pay attention. You start with x equals, you start with y equals, and you start with t is between two things. All right, take notes so you know how to do this. This is one of the key skills from this unit. It's called a directed line segment. Okay, so I would suggest this will work every single time. If you want to say it's between 0 and 1, that's the easy way to pick t. Just always make t between 0 and 1 every single time. Then, if you put in 0 right here for t, you figure out, what do I want x to be when I put in 0? Well, I want it to be 1. It's starting here, right? So I want it to be a 1. And then you have to have a t in here, otherwise it's not really a, what do you call it? It's not really a parametric unless I have a t. So I'm going to say 1 plus t, but this is an important part. Otherwise this would be way too easy if it was just 1 and then the y is 2 plus t. No, it's not quite that easy. But 1, 2, see these 2 points? There they are. But it's not just t. It's this t being 0, when you put in a 0 for t, do you get, no matter what you put next to this, on the first point, it's going to be a 0 and a 0, and that'll cancel that part. And so, yay, you could put any number you want right here. So be strategic about what number you put there. What you put there is how much more do you have to grow from here to here. So if I wanted to go from 1 to 4, I needed to change by 3. I needed to add 3. And how about from the 2 to the 5? I wanted to add 3. I'm done. And I would check it to make sure that it worked. How would I check it? I'd put in 0. When I put in 0 here and here, I knew those t's are going to make that part cancel, so it's 1 and 2, and that's what I wanted. And then for this, I always use 1, and then I now put in a 1 right here and here, and then I have 1 plus 3 is 4, and 2 plus 3 is 5, and that's the point I wanted to end with. So if I was going to summarize this, I'd say you always write x equals and y equals, and you always have t. And I'd always put it between, and I should have had or equal there, sorry, 0 and 1. Then you always put the first point right here. And that's the first point. You always have a t here. And then this is the only thing, look at every single time. You have exactly what I have right here. Your first point, it has to be filled in from whatever the first point is. And then you put the change in the x right here and the change in the y right there. So let's use this little formula and see if you've got this. I'd like you to take 4 comma 5 and go to 5 comma 9. Would you please write me a directed line segment parametric equation? I want to impress your mom and dad tonight. What'd you learn today? Well, we're using parametrics, and so we made a parametric description for a directed line segment. Guarantee you they'll come back with something like, we never did that when I was in school. This is really one of those obscure kind of topics, because it's parametrics, which a lot of people never learn in the first place. And a directed line segment, holy crap, it's not actually that complicated, but it sure sounds impressive. So Jack P, what did I always tell you to start with? X equals and y equals. T restraints between 0 and 1. Soren, what could you put here? I know you've got a way you can do it without this, but for using my way, what should I put there and there? Hold on, 4 there and 5 here. And now you're doing the next part, which I wanted to consider like the last part, which is like, how much change is there to put in front of the t here? And go ahead, Soren. Plus 5t. Wait a minute, plus 5t? 4 changed into 5, so that was just plus. There we go. Plus 1t plus 4t. Is there other answers? Yeah, we demonstrated that earlier this hour when completely different ways of doing it, and they had ways that worked. If you're like, oh, I have something different, I think it works. How do you prove it? dxy. We'll just prove that my way here worked. When you stick in 0, you really get 4 for the first x, and then you get 5 for the second one. Yep, I do. And then when I put in 1, I will get 5, and then 5 plus 4 is 9. And yep, that goes from 4, 5 to 5, 9. Yes?
How do we know that it works for all the points in the line? Or does it just work for those?
It will work for all the points in between it too. But the way we set up our t, we just have two integers, 0 and 1. You could actually have made t anything, but it would just be much more complicated. So it will work. I don't really know the answer to how could I prove that. There's probably a really complicated proof for it, but this will work. If you wanted to, you could try putting in something between 0 and 1, like 1/2. And then you'd see that that point is actually between 4 comma 5 and 5 comma 9. If you put in 1/2, it would end up right in between them. Okay. All right. So that's called directed line segment. And there's one last thing to learn. Y equals 2x plus 7. Go back to the basics. Do you guys agree that that is a rectangular equation? It goes on forever in both directions. You could graph it, right? It'd just be a straight line, wouldn't it? Goes forever in both directions. Make it into a parametric. Far more people figured out the directed line segment than I thought, so I'm not going to teach you. We'll see if somebody can just figure this out. How would you make that into a parametric? Oscar, what are the things a parametric has to have?
X, Y, T, and then like the limit.
Okay, good. So I got my y already, and then I got to have an x equals, and then I have to have a t limiting between something and something. I agree. Yes?
Well, it wouldn't necessarily have to have a t limit this time, because it's a common.
Oh, you're saying that since this one is going to go forever in both directions, how about if we just say that the limit then is from negative infinity to positive infinity? Kind of like that. Go ahead.
I got y equals t plus 7.
Okay, y equals t plus 7. Keep going. T over 2. Now, will your equation give us all the same points as the original equation? We will find out in a moment. I am going to show you the normal way that you do this, but as I respect that you've probably got a way that works. The normal way to do this is you keep it simple and you say, don't you want a t over here? I mean, you have to have a t in there, don't you? X equals something with a t. So just keep it simple and say x equals t. And if x equals t, then x equals t. That's a t. And there's my equation. Now, can you do it other ways? Absolutely. But let's take some points that we should know are on this, like it was originally y equals 2x plus 7, and then this you see an xy, a few points that actually should be on it, right? What if I put in 0? I should get 7. What if I put in 1? I should get 9. What if I put in 2? I should get 2 times 2 is 4 plus 7 is 11. You get what I mean by that? Now let's see if your way, this one, works. So if I put in 0, I get y equals 7, and I put in a 0 here. 0 over 2 is 0. Oh, it's working so far. But working for the first point doesn't necessarily guarantee it's going to work for the next point. What if I put in a 1 right here? 1 plus 7 is 8 and 1/2. That's interesting. Is 8 for y and x equals 1/2. I have to actually go back and put it in here and see if that would work, because 1/2 comma 8 is a point that works. Huh. All right. You found another way. And I love it, but I can't explain how you did it. So I'm going to stick to my way that I know is always going to work. But you were correct. There are a million ways. In fact, there's an infinite number of ways you could get this answer. But this little way I'm teaching you will always work, and it's super simple. y equals, no, they'll never give you a parametric in the first place, so it'll be like y equals x squared plus 7. And then that's it. They don't say anything else. And then they'll say, make that a parametric. And you go, well, I know it needs an x equals, and I know it needs a t limit. And then you go, just let x equal t. And if x equals t, then I put a t here. And was there any limits on the original equation? No, there wasn't any limits, so I can say this is between negative infinity and positive infinity. That equation would have gone forever, so this one will too. That's all there is to it. Is that a parametric? Yeah, it's got a y equation and an x equation. They both have t's in them. And then it's got a t limit, which in this case is no limit. All right, you learned everything. You know what happens tomorrow? Take a little quiz on it. It's on paper. Counts. Not in the summative. That would be too harsh. Okay. Counts in the formative, though. So, what do you do tonight? Practice. There's practice problems, as usual. There's an answer key that's posted, as usual. Strongly recommend you practice, because there's a quiz tomorrow in class. It's homework, but it's basically you're going to do your homework in class. And this one is not a group quiz. Okay, this is just you and your brain and what I just taught you with what I taught you yesterday. Quiz tomorrow. The next day, Thursday, will be a review. Friday's the test. Okay? It's a study tonight. And that's all I've got for you for today.